Welcome to session 3 of our course in Synthetic Intelligence 101. This session is Real AI from First Principles. We're going to define what we mean by real AI in a minute, but we feel this is necessary because AI today, and for the last 60 years, has really been called modern alchemy because its practitioners don't really agree upon what it is they're doing and what the goal of it is. And so they're just trying things to see what will happen. And sometimes interesting problems are solved, and sometimes, like the alchemists, they kind of blow up the lab, which might be a fair summary of what's going on in AI today. This is session 3 of our 9-part series, which we are putting together to help people understand the fundamental principles and the origins and what it is that New Sapiens has built, because there's no other resource out there, because it's completely unique. No one has ever done an approach like this before. Our objectives, first of all, to understand what is the goal of AI and why do we desire it so. Define intelligence. Understand the difference between intelligence and knowledge, data, information, and knowledge, language and knowledge, and models and symbols. The goal. Humans are separated from other known species by the degree to which we adapt our environment to suit us rather than the reverse. We are able to do that because we can build tools to amplify our natural powers. And building tools is predicated on our master skill, our natural ability to acquire and apply knowledge of the natural world. So a technology that would amplify our master skill would be the ultimate machine. The Allure, AI is kind of the ultimate value proposition. And this is something that's certainly been appreciated by people when they talk about real AI, that is the AI that will amplify our natural skills, because it would lead to a world of unlimited productivity, as we've imagined, and it's been imagined from the beginning, that we could eventually use AI to build intelligent robots, and they could build other robots and go out and create the infrastructure of civilization for us and do all the tasks that humans find difficult or tedious or boring or dangerous, and usher in a new millennium of wealth and plenty, such that the basic necessities of life may be virtually so cheap as to be virtually free. So there's no question about why AI, should it be achieved, is something desirable. So everyone argues about what artificial intelligence means, but it's not because they disagree about the word artificial. So what then is intelligence? As we've said, humans adapt their environment to suit themselves. Other animals must adapt to it. This is because humans have knowledge of the world. So the essential definition of intelligence is that it is a process or processes existing within an information processor like a brain, an organic brain, or a computer that produces knowledge. Now, we don't know what's going on in the brains of other species. Pilot whale here has a larger brain than human beings, and even a larger neocortex, which is where intelligence is thought to reside in the human brain. Does it have knowledge of the world? Well, we don't know, because it has no hands. We don't know how to communicate with it. And so we don't know what's going on in there. Which brings a kind of refinement to this notion of intelligence, that the knowledge exists for the sake of changing the world. So knowledge, or valid knowledge, or real knowledge is knowledge that allows you to go out and do things and predict the results, say, of your actions, and to envision things that might occur that haven't occurred yet. So AI comes out of that, very, very simple. AI is intelligence in a machine. But keep in mind that a definition of intelligence includes basically the part that produces knowledge, which is the human being's intellectual capacity. The human brain has a lot more going on than just its intellect. We have feelings, we have motivations, we have perceptions, all of those things, some of which are ancillary to our intelligence. If we didn't have senses, we wouldn't be able to create knowledge of the world. But that is not the knowledge itself. So I think we see a lot of confusion out there today when people are saying, well, We're creating AI because we are giving a machine the ability to recognize an object or picture. Other animals do that very, very well. And we don't say that they're intelligent because they can see or have perceptions. AI is about creating an artificial intellect. That's it. It's not about creating an artificial human. So there's a lot of confusion out there about the difference between data, information, and knowledge. Let's try to clear that up. This is not controversial. These are generally agreed definitions. Data is an individual piece of information, such it might be represented by a symbol or a single assertion of fact. My address or the sky is blue, a single assertion. That is a datum. Information, though, is when you take lots of bits of data and you organize them in some way, such as in a database, or say a telemetry stream of measurements coming from a spacecraft, or a statement in a language. That is information. Now, knowledge is not only in the general sense that the broadest term here is the word information, but knowledge is a very specific type of information. It's organized data, it's organized information, but it's of a special kind. And that is that it is an internal model of the external reality. So that is what knowledge is. We'll bring more definition to that concept. Up to now, computers have been really good at processing data, and they're really good at processing information. But until now, no one has found a way to endow them with knowledge, that very special type of information, such that once they had that knowledge, they could use their processing power to extend, acquire more of it, and extend what they know and apply it to solving problems. Language and knowledge. There's a lot of confusion and misunderstanding about the relationship between language and knowledge, but it's really not that hard if you stop and think about it. So first of all, understand that all languages are programming languages, whether for a computer. In this case, they're programming languages, and that all languages, whether it's mathematics, computer languages, natural language, consist of statements. And these statements are an organization of symbols with syntax that are designed to be processed in an information processor. Like in a computer, we'll go through a program line by line, processing each statement, and then going off and doing something and creating something on the basis of how it decodes those statements. But when you think about it, human language is exactly the same. So a statement in the human language is an instruction for the listener or reader to assemble some ideas or concepts that they already have in their mind and assemble those into new ones. So the words in that message are kind of like the parts list. Go up and look up this idea in your concept warehouse, and the grammar kind of gives you hints on how you should assemble them together, right? Man bites dog or dog bites man, the same parts, but they're arranged differently because of the syntax in the sentence. So if you want to comprehend language, you would have to have enough basic knowledge of what words mean that would be commonly used, which is common sense knowledge of the world, in order then to be able to use it to communicate and articulate ideas using language. So language is a communications protocol, and it consists of executable messages. So what does that imply? When you think about it, that leads you to some rather startling realizations. As we say here, the Library of Congress is a great repository of knowledge. That's how we talk. Of course, you would say true, but the reality is, think about it, it's false. There's not knowledge in there. There are words, messages, executable messages that have to be executed in an information processor. And then that creates the execution of that code, creates the knowledge in that processor in the mind of the reader or listener. And the same if you write a computer program that processes and decodes that knowledge and that language in the same way that the human does, that is functionally the same way, to relate each word in the message to a pre-existing concept and analyzing the grammar and syntax to assemble pre-existing concepts into new ones. So when you realize that, that really highlights that this notion that they're doing now of using statistical processes of the statistical probability that one word will follow another word is an entirely alien way. It's not processing language at all. It's just processing repositories of data, ones and zeros, to find patterns in it and stringing them together according to probability. So it's not what ChatGPT does is not language. What it outputs is text, but it's not language because it's not communicating. And it was created by a process that is entirely alien to the nature and the design of natural language. Now, this is an important important distinction to make as well. The difference between symbols and models. In all of AI in the past 60 years, there's been two major approaches. One is what that we have today with ChatGPT and the other language models, basically machine learning, which uses artificial neural networks. It's generally called connectionist AI. But previously, the first wave of AI was called symbolic AI, and that's where programmers try to represent knowledge in symbols. So symbols, though, require quite a bit of processing, and that's the relationship between a symbol and what it is a symbol of is an arbitrary convention. So you have to juggle all those arbitrary conventions and manage them in order to try to get down to the information that is really significant for you. So here's a symbol right now. I don't know if you recognize that. It's a chemical formula where each letter has a correspondence to an element, and the numbers have their particular meaning. So you have to decode that to learn something about the molecule involved. This happens to be glucose. Here is a picture of a model. Of course, so it's a picture of a model, but pictures are models. So pictures and models don't symbolize. They don't represent things. It would be more proper to say they might resemble reality, but they don't represent it, because a representation is the relationship between a symbol and an arbitrary thing. Representation is arbitrary. So that is kind of, you begin to see why symbolic AI failed, because they tried to represent knowledge in symbols, and it turned out that the only way they could do that was basically making each statement in the program, which composed of symbols, to manipulate other symbols. There were too many facts. They were basically operating at the level of data. And so it didn't scale, because if you want to do something intelligent in a machine based on knowledge, you will never be able to assemble the facts together and integrate them into a model, which is what knowledge really is. So models are much more compact in being able to convey information about the world than symbols are. So the knowledge, our general knowledge, is a model of the world. And if you think about what that might conceptually look like as a model, it turns out that it's not really much different in your mind when you think about it than molecules or material objects, which are made of molecules, which in turn made of atoms, in that you have concepts which are made of smaller concepts and which all have relationships to each other. So you have a network of ideas and concepts which can be broken down into smaller concepts. But this information structure, how do you know if it's real knowledge as opposed to a misunderstanding of reality? Because you can't tell by the structure. Well, first of all, as we say, qualitatively, it's a model. Quantitatively, knowledge has to be of sufficient scope and fidelity, that is, it's a good model, that is useful to predict external phenomena. So that's what we're trying to get in here. We're put knowledge in the computer, so like us, computers can predict what will happen and envision new ways, putting together new structures, new information structures of new knowledge and of reality that hasn't been built yet. Now, this notion of knowledge, the study or philosophy of epistemology, refers to the philosophy of knowledge. But the idea that knowledge has a structure like this, and that its relationship to reality is the same as the relationship of models to prototypes, that of which they're models, is really quite a radical departure from traditional epistemology, which has always been concerned with the truth or falsehood, basically, of an individual assertion. So this is more like structural epistemology than being concerned with truth or falsehood per se. Here we're talking about the utility of prediction. So synthetic knowledge would be to find a way to engineer that engineering structure and put it into computers. That is also a radical departure from what AI has been for the last 60 years, which has been based on mimicking the intelligence part, features of human intelligence, that is the processing. So if you focus on the process of intelligence rather than on the desirable end result of that processing, then you're going to have to kind of reverse engineer the human brain. And we don't know how the brain works. It's very, very difficult. But in the end, the task will be to emulate those natural processing by which natural intelligence creates knowledge, and so that a computer starting with kind of a blank slate can create that desirable end product. But the last 60 years has shown how problematical that is, because what AI has typically done is create imitations or illusions or simulations of intelligent behavior rather than the real thing. And quite many years ago, a philosopher named Hoagland coined the term synthetic intelligence to on the analogy that that you could create real intelligence through engineered means directly, as opposed to synthetic, or rather to say artificial or imitation intelligence. So he made the analogy between an artificial diamond, or rather, not an artificial diamond, I should say, a imitation diamond, or a engineered diamond, a synthetic diamond. Synthetic diamonds are real diamonds, right? They have the same crystal lattice. Whereas imitation diamonds, like rhinestones, may look like diamonds, but that's only a shiny illusion. It may look good, but you can't use one in a drill bit. So once you take that approach, what is the scope of it? Well, and how do you do it? Well, the process of synthetic knowledge, of creating synthetic knowledge, and we'll get into the next session, we'll get into that in detail in other sessions, how we arrived at this approach. But the notion is that you take real knowledge in a human mind and you curate it in such a way with the toolkits that we've done to create an information structure that's processable by the computer. And that's a direct process. We're not examining how the human mind creates that knowledge. We're just introspecting it in our own minds. And then through a toolkit, we create a processable information structure. So how much do you need to do useful things? Well, what we're starting is a model of a common sense world that would have sufficient scope to endow computers with the ability to use natural human language to communicate and articulate ideas, which is unprecedented. No one's been able to achieve that. So what does it look like, that model? Well, you can imagine it, again, as a single integrated information structure where each node in a network like this represents an idea. I shouldn't say represents an idea, models an idea. And that each of those ideas is connected through relationships to other ideas into a single structure. And so you create a model of the world inside a computer, which is derived ultimately from the model of the world inside the human brain. So let's review and go back and look at some of the definitions. Understanding these definitions and understanding that these are precise definitions. We're not being vague or ambiguous about these. We mean exactly, this is what we mean by these words. And these principles will be fundamental as we look into how synthetic intelligence works. So knowledge, an internal model of external reality with the utility for prediction and control. Intelligence is information processing that creates, extends, or applies knowledge. Artificial intelligence is simply intelligence in a machine. It's trivial. Here's some terms we didn't talk about, but they're very much around these days. They talk about narrow AI, and that's what the pursuit to imitate human intelligence has led to. And it's an aspirational term. Calling it AI is aspirational for techniques that may lead to, or support intelligence in the machine, but don't actually achieve that. Arguably, all the AI that's been created in the last 60 years, exclusive of what we're doing here at New Sapiens, is narrow, not general, because knowledge is general. Okay, that's the key. That's why they sometimes call it artificial general intelligence, because artificial general intelligence produces knowledge, and knowledge is general. Data and information are narrow and brittle. So I'd like to thank you for your time. Join us for our next session, which will be coming up in a week or so, and will also be posted on our YouTube channel. Until then, please check out our YouTube channel at New Sapiens, and our website, newsapiens.com, mysapiens.com, our website that talks about our exciting product, the Companion Sapiens. And please visit our campaign page for our crowdfunding campaign that's going on now on Start Engine. A lot of information on all those sites. Thank you very much. Thank you very much.